Another vital, yet often overlooked factor supporting the view that aging reflects malnutrition is the gradual deterioration of cell membrane composition due to deficiencies in essential fatty acids, particularly omega-3s like EPA, eicosapentaenoic acid, and DHA, docosahexaenoic acid. Cell membranes are not static barriers. They are dynamic structures that must maintain precise fluidity, permeability, and flexibility to support critical processes like nutrient transport, receptor signaling, and cellular communication. The unique biophysical properties of omega-3 polyunsaturated fatty acids allow membranes to stay fluid and responsive, which is especially important in tissues with high turnover or electrical activity, such as the brain, retina, and cardiovascular system. When diets are chronically low in omega-3s, a common feature of modern dietary patterns heavy in processed foods and excess omega-6 fatty acids, cell membranes incorporate more saturated and omega-6 rich fats, leading to increased rigidity and loss of proper membrane function. This imbalance alters receptor conformation and disrupts key signaling pathways involved in insulin sensitivity, neurotransmission, and immune modulation. As a result, cells struggle to communicate effectively, contributing to the systemic dysfunctions often attributed to aging, including cognitive decline, metabolic syndrome, and chronic inflammation. Research supports that individuals with higher lifelong intake of EPA and DHA exhibit more youthful membrane profiles, with better preservation of membrane fluidity and signaling efficiency in neurons, muscle fibers, and immune cells. These people tend to maintain sharper cognitive abilities, better cardiovascular resilience, and stronger inflammatory regulation into older age. Conversely, the brains of older adults with low omega-3 status show stiffer, less responsive neuronal membranes, contributing to the slowing of synaptic activity that underpins age-related memory loss and impaired learning. Moreover, clinical studies have shown that supplementing with omega-3s in middle age or later can partially restore membrane fluidity, improve neurotransmitter receptor function, and enhance cellular responses to external signals. These findings highlight that what appears as membrane aging is not an irreversible degenerative disease process, but the predictable outcome of a lifetime of suboptimal essential fatty acid intake, a form of nutritional neglect that can often be corrected with meaningful benefits even in advanced years. This understanding also helps explain the remarkable longevity and cognitive health seen in certain traditional populations consuming diets rich in marine omega-3s, such as Inuit communities or Mediterranean coastal societies. These groups maintain a natural balance of omega-3 to omega-6 fatty acids, preserving flexible, functional cell membranes well into old age and exhibiting lower rates of dementia, cardiovascular disease, and other aging-associated disorders. By reframing membrane deterioration as the direct result of lifelong essential fat deficiency, we can empower individuals and public health efforts to prioritize balanced fat intake as a cornerstone of healthy aging. This approach rejects the notion of membrane aging as a mysterious or unstoppable degeneration, instead recognizing it as a clear and modifiable outcome of nutritional choices that can preserve cellular communication, protect organ function, and extend vitality far beyond what many now consider typical aging.